Hi, I'm Dala, and today we're gonna be doing something different. Most of you probably subscribe to me for some more technical content compared to watching me turning wrenches. But I don't know, there are people in both camps. But today, let's look at some CAN database management. Some of you might know that I maintain this Leaf CAN bus repository found on GitHub. And here I have stored all my CAN findings, so these are very useful if you're doing some reverse engineering that relates to the Nissan Leaf. But there hasn't been really that much info on the newer 2018 Plus model. So today I'm gonna be doing just that, creating a database file for the 2018 Plus ZE1 model of the Nissan Leaf. So that is the 40 kilowatt hour and 62 kilowatt hour battery pack. I was very lucky and got sent some CAN bus logs from a friend in America. And the files that I got was this one file, which is the 62 kilowatt hour EV CAN battery only file, which contains just the battery, which is excellent. That way we can see which messages are originating only from the lithium battery controller. And I also got some full logs when the vehicle is quick charging and when it is idle. So yeah, let's open this up and see. I'll be starting from this database file, which is the EV CAN for ZE1. That is the 2013 to 2017 model. So here you can see the content of all the messages. So we'll use this as a starting base. So I'm just gonna close this file and I'm gonna rename it to ZE1. And let's open it right back up. And best would be maybe to start with opening the EV CAN for the battery only. So let's do that. The file format that I got sent, it contains only it doesn't have any timestamps, so that is a bit unfortunate. So we can't figure out how periodic these messages are. Or we could with some educated guessing, but let's not guess anything here. So let's see. We know for sure that everything here in this list comes from only the battery, which is excellent. So if I sort here the old messages, and we can see everything here originating from the LBC. We have 1 dB, we still have 1 dB. We have 1 DC, still have that. 1 ED. Seems like 1 ED is a new CAN message that wasn't present in older vehicles. So I'm gonna go ahead and add a message. I'm gonna name this one. I'm just gonna follow the same style that the other messages had. So I'm just adding it here. Now we have it there. The hex ID for this message was 1 ED, and it is length 3. Now we can write that this originates from lithium battery controller. We don't have the period rate here, so I'm just gonna set it at unknown. Nice. What about the content of this one? It seems to be a fairly quick message. It comes at the same rate as the 1 dB and 1 DC message, and those one are running at 10 millisecond. So you know what? I'm just gonna write 10 millisecond because it's a fast message for sure. But the content, it is 3 bytes long. It seems to have some sort of repeating pattern. This second byte, it goes from E0, E1, E2, E3, and then back to E0. So this bit here might actually be maybe a mux, and the last field can then be the actual value, or the last bit could be the CRC field. We're not exactly sure of that yet. But let's add these 3 bytes at least, so we have them. So I'm just right clicking and adding new. So now you can see that I have populated these ones. So I'm just gonna copy this from another message so I get the correct name, or not correct name, but the same name as what I am having. So we have 3 unknowns. Well, the first one seems to be FF all the time. I'm just gonna make a comment here. And I'm just gonna add my name to it. So the first byte is unknown. The second byte, we're just gonna put mux question mark. It could be this multiplexer for the last piece. And the final value then could be either mux value or CRC. And let's continue with the question marks because we are in guessing territory right now. So there we have it. First message is added. Let's continue then. Let's look at what else is being sent here. So we had 1dB, 1DC, 1ED, 55B. 55B, we still have that. Then we have 5BC. Yes, same as the old one. Then we have 1C2. That one seems new. Yes, this is also a new message. So let's go ahead and add that. Add message x1c2 ID. And this message has only 1 byte in it. This is also then originating from the lithium battery controller. So I'm just gonna copy this text and paste it here. And it is showing up at the same time as these ones. So this is also, or you know what? It could be false. Oh no, it is 10 milliseconds. Yeah, let's go with 10 milliseconds. It's not 100% confirmed, but I'm pretty confident. Oh, I forgot to set this field also. These are the official names that Nissan uses in the documentation. So HVBAT is the lithium battery controller. I'm just gonna go ahead and add that also for the one I forgot. Yeah, 1C2. So what does it contain? Only one thing. Okay. Let's add this signal, and it is still unknown what it contains. Whoops. 1C2. If we look at the content, 5C, 5D, 5E, 5F, 50, 51, 52, 53, 54 loops. Okay, so this seems to be a looping value. Maybe it's just some still alive message or something. Maybe they needed some more freeze data checking. I don't know. Let's add a comment. Loops between 50 to, what was it, 5F. Then repeats. Okay. So that is that. Let's continue. Now we have the 1C2. Then we have 380. That's a bit weird. I remember that 380 was actually used in the oldest gen Leaf, the ZE1, but then it was a message originating from the onboard charger. As you can see here also that the OBC has on the AZE0 it has 390. and it was 380 in the first gen. Seems like they have started to use the same message ID again for the battery. This is very strange. But okay, I won't question what they did. I'll just note this down. 0x380. The length is 8. There is a lot of things in this message. This one is not running at 10 milliseconds. This one seems slower than that. Lithium battery controller. This one is slow, but I don't know how slow it is, so I'm just gonna set it like that. And it is sent by the HVBAT. And this one has a lot of content, yeah. So let's add the signals. This message is full. And then I'm gonna go ahead and copy this text, since we don't know yet what is in here. Yes, and as you can see, I'm just adding them like full length for each byte, but most likely the content that is actually in here is shifted all around in this message. So this is just a placeholder. Like if we look at this message, for instance, you can see that some of the values are like 10 bits long. It goes in between several bytes, and some are only half bytes. Some places are muxed, like there's a lot of, yeah. So we can't know for sure yet, but this is only like the rough draft. But looking at the content quickly, 380. Let's do it like this. Let's go down. I am looking here at the bottom. It seems fairly static as I'm stepping through the log. Oh, there was some shifting going on there. But the last part is probably a CRC message, because they really like to put CRCs on most messages. So I'm gonna go ahead and put that as a comment. Most likely CRC. Okay. I can't do much with this data. Like I see that there is something here, but I can't guess without a car. I would have to have access to it and do some manipulation of something in order to get these values to move. But yeah, that's all that we can do here with this message now. But okay, let's continue. So that was the 380. Is there something else that we missed? We had the 55B, 5BC. I can't really see any. Oh, here we have something. 59E. Did we have that one? I think so. $59E, yeah. Oh, interesting. They added something. Something on the last byte is added for sure. Maybe they added a CRC to this. Let's go ahead and add that. And this message, I'm just gonna use this button to shift it in here. And let's just call this the CRC for 59E. Or actually, before we do that, let's see if it... it's static all the time. Then it might not be the CRC, or it could be. Let's put it as unknown. 59E, and it's the last byte, 7. Something else, static in log. Like that. Okay, what else do we have? We have 5CO. 5CO, we still have that one. That one is filled. This is the one which contains a lot of data about the battery heating, the averages for temperatures and voltages and internal resistances, etc. I don't expect this message to change much. So yeah, let's continue. Then we have 5EB. 5EB. Hey, is that one new? Yes. That is also a new message that they added. So let's add that. 5EB. This is a slow message. I don't know how slow. So let's copy the text from this one. HVBAT. This one is also filled with data. Let's quickly step through it. This one is initialized at FFFF all the time. When you see a message that is like FFFF, it's usually like the data is unavailable. It's just, since the battery here is not hooked up to anything, it's just being powered on and sending out messages. It might be missing some data so that it can't fill in here. So it's just initialized to FF, unavailable value. Or that's just a guess. But one thing you can do here when it is in this FF state, it's kind of interesting to see that there is a 0 here. So that means that usually if we add the bytes, this might be easier to see. Let me populate this message. It usually means that this byte actually doesn't have any data in the first one. So if I would guess, I would set this length to 4 and say that there is no data here. I could be wrong, but that's a guess. I will add this as a comment. Can't spell. And I will also copy this. The reason it's good with labels is that if you start trending this using the database files, it's good to have some names on these instead of just new signal. Okay. Now we have that, and let's continue. 5EB. Do we have anything else here? I think we're starting to be done with this file. Yeah, I can't see any new messages. 5BF. Do we have that? No. 5BF is a new one. Let's add that also. There's a lot of good stuff here in this log file. So 5BF. It's 8 long. It comes from the HVBAT. It is sent at an unknown period rate. It has some content here. Let's quickly search and see how static this is. It's not that static. Or if I quickly step through, there was some change here, and also the final byte. So I think we'll just add these two fields that actually have something. So let's add those two here. Let's add two, and let's put them at the correct place. So this was on the 4th, and this one should be on the last one. And again, could this be the CRC? But the first one is actually, there is something here. Unknown 5BF. It's byte 4. Unknown 5BF 7. Can't spell. Okay. Maybe now we are finally done. Let's quickly look, or carefully look through this again. 5BF we had. Yes. We are done. We are done with this file. Let's move on to the next one. Let's quickly save this and open up the next one. Okay, let's continue then with the more interesting file. The one where the car is actually on and all the modules are active. So here on the right then we have this log, and I can immediately spot some new messages. But before we add all the new messages, I thought it would maybe be good to just delete messages that aren't present anymore. So let's take a quick check and see if we can delete anything. I can see that the 11A is there. 1D4, is that there? Yes, that one is there. 1DA, that one is still there. 1DB, whoops. 1DB, C, ED was the new one. 1F2 still there. 284. That's the ABS. That one's still there. 380. Interesting. No 380 in this one. Okay. 390. Yes. 393. Yes. 45E. No 45E. I think we will leave this still. This might be some special wake up message. I think this one only appears in some logs on the ZE1. So let's keep that. Same thing I guess with 481. Yeah, 481 is in this log. It is the same length. It's length 2. So let's keep that. Then we have 50A. Yep, let's scroll down. 50A is there. 50B. Yes. C. No 50C. Seems like they have gotten rid of the 50C message. Let's open the one while it is charging and just see if we get some 50C message there. No. 50C is no more. This message will be removed. Let's continue. 54A. That one is still there. 45. That was that one. A bit scrambled now. So 59E. That one is there. I don't like this program when it tries to be clever with the sorting. Now let's go. A. B. C. F. A. 55A. B59E 5A9. 5A9 is something that I remember. Here it says that this message appeared after recall update in March 2011. Probably VCM to TCU for Cowings. So it seems like they don't need this data anymore. Just double checking in both files. Yeah. Okay, this message is no more. Good, since we never figured out what it actually meant. So nice that we can delete that. Oh, where were we now? Yes, let's continue. 5B9. 5B9 is also not present. This is the active fuel bars and charge minutes remaining. 5B9. Can't find. Okay, 5B9 is no more. Let's remove that. Let's continue. Then we have 5BC. I guess this one has to exist. Yes, of course. 5BF. No, 5BF. But wait a minute. 5BF was the one that we had in this log. Weird. Okay, let's keep that. 5C0 exists. 5EB exists. 603 is the boot up message. I guess that one is still the same. Same with 679 that appears when you plug in the J1772 plug. Okay. Now we have deleted some stuff that is no longer present. I mean, of course, I could have been wrong there and deleted something that actually should be there, but if I did so, it's no big deal since we still have the old database files that we can easily pick this data from. So yeah, let's continue. So now that we have removed this, we can add the new stuff. And I can, if we scroll to the beginning, I can immediately see some new stuff. There is this message 120 and 108 that is not in the database. So let's add those. X120. This one has a length of 4. We don't know who is sending it. So we will put question mark. Let's look at the content real quick. It seems to be, if you look at this this one, it seems to count from 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, so some counter there and maybe a CLC. Let's add those two at least so you can trend them if needed. Put them in the correct place. Add comment CRC. Counter. It goes from 01 to 0F. And oops. Nice. Nice. Let me just add the unknown text. And this is for the byte 2. And this is for the byte 3. Okay, that's 120. Then we had some other. That was 108. Let's add that. And that one has a length of 3 bytes. This is also unknown who is sending this. As a tip, if you want to actually figure this out when you have the car, you can just unhook one module at a time. And you should find who is actually the sender quite easily. Let's see what contains data. Okay, so this is another one of those. It seems to, if you look at the last entry here, it seems to loop between 1 to F. Maybe they stay in sync. Maybe it's like two modules that. Oh wait, 102, 10. Nah. Or nah. It will require some further investigation. But let's put these where something is actually happening in the message. And let's use the same style. So it's byte 1 and byte 2. And this was counter. Let's see how it loops. 0, 0 to 0F. And loops. This is a theme that we seem to run into here. CRC? Question mark. Okay, let's continue. 3B8. That one is also a new one. There seems to be some interesting data here. This is during standstill, so not much is happening, but there's definitely something going on in this message. Let's add that to the database. Oops. 3B8. This one has a length of 5 bytes. And we don't know who is sending it. But we do know that every byte in the message contains something. So we will fill it out and we will add some generic names. Yay. Generic names, the best. 1, 2, 3, 4 and 5. Like so. We don't know, we won't add any comments because I can't speculate. Today we're just adding the messages. Okay, so we got that. This is something else. Oh, where were we? We had 3B8. 1C2. Wait. 50A, 50B. 1ED. 284. Did we have that? Yeah, 284. And 355. That one is also a new one. It looks kind of empty, but let's add it. 355. It has a length of 8 full bytes, and we have no clue who is sending this. Let's look quickly at the content, how much activity is here. It seems to be very static. If I quickly look through it, there's just something here and there. Let's quickly look at while the vehicle is charging, since we have that log as well. Let's see if this starts to contain something else then. Nope, it is simply static all the time. No change whatsoever. Bummer. Boring. But let's add 2 signals to where the static data actually is. So this one was at byte 4. And the next one is at the byte number 6. Standard procedure by now. I hope you're not too bored looking at... Oh, actually you must be quite bored to actually go through and look at this video. It is quite boring. I commend you for watching this. You must be really interested in learning some CAN reverse engineering. Okay, that was 355. I could actually add a comment here. Static while idle and charging. It's the same. Okay, 355. Do we have anything else? By quickly going through. C5. 5C5 is new. Let's add that. We have no clue who is sending it, but we know that it is 8 bytes long. Let's look at the actual content. There's some static data here also. This was while we were charging. Let's look at the non-charging. It's the same here. Okay. We will add those 3 fields. And some name. It was 355. 5C5. 0, 2, and 3. Static. In box. Great. That was 5C5. Let's continue. I can instantly see 5CD here also that we don't have. No, we don't have that. So let's add that. 5CD. This has length of 5. We don't know who is sending this yet. If you own a newer Nissan Leaf and you want to help with this, you can not risk your car, but you can. It would be interesting if someone could disable one module at a time and see actually which module this is coming from. That's a very good start before doing any other type of reverse engineering. Because if you don't know who is sending the module, you're not sure if you're supposed to be getting some temperature or some current value or battery value or something like that. It's gonna be impossible. I can quickly see here 625. Guess we don't have that one. That one is also new. Let's add that. 625 is 6 bytes long. No clue who is sending it. But it is filled with stuff. And it seems to be very static. Is it static in both logs? Yes. Yes, it is. I will fill every frame for this message. Six, 2, 5. There we go. And we won't do anything more than that. Okay, let's continue. For BA, that one is new. I can instantly tell. It seems very empty. Oh, it's very empty. It's a very big message, but it doesn't really contain anything. And it's only active while charging. That's interesting. Then it's probably related to quick charging somehow, because this log comes from quick charging. So this is very interesting. So let's add that message for BA. And we don't know who is sending it, but we can write that it is only present while quick charging. That would hint towards the OBC, the onboard charger. But I won't tick that yet. Or actually, well, when it's question mark, I won't do that. But I will add a new signal. There's at least something here that is related to charging something. It's solid 3 all the time. Okay, nice find. Let's continue. We have also 4BB. That is new. Is that also only present? Yeah, that one is also only present while charging. And that one is 2 all the time. Okay. Okay, let's add that. I'll put the same text. And same thing here. I will add unknown 4BB0. Nice, nice. Good finds. Here we have something also. 3C8. That's new. Oh, that one is also only active while charging. Very interesting. 3C8 is 8 in length. Same text. 3CA. There's a lot of frames here. I will add these off camera later on, but you get the picture. I just create these empty things here. But let's focus on getting all the messages now, because this video will be so freaking long otherwise. We will also add the X3C9. This one was also only present while quick charging. Let me confirm that. 3C9. Let's see, so I don't... A notepad is not a very good search tool. But yeah, 3C9 only active while quick charging. Okay, what next? If I sort by name, let's see. Let's see if we have something interesting here. 1C2, 11. 1CB. 1CB is new. That one is available all the time. Let's add that. But we don't know who sends it. But it is there. Okay, this one I know. At least this next to last byte. Let me just add the messages first and I will explain. Let's push this one down here. And yeah, no, I can type in the bits also, but it's more fun holding the button. Okay, this message is a prun message. Let's add, or it could be a mux, but most likely it's a prun. I can give you the description for prun in a second. Let's just write prun-1cp so we know which message it belongs to. So if I quickly wait, which message contains prun that I know of? Maybe some, or prun. Yeah, here. LB prun 55B. It is a detection of frozen data message. This goes between 0 and 3. So I will copy this text and I will add it to the latest one here. Because I know this. I am certain of it. But I don't know who is sending this peer-on message, but they are sent on some important messages have this in order to detect as soon as one CAN message goes missing. It does this. Okay. There's some content here, and this is most definitely a CRC. Then if this message is so important that it has to have the peer-on diagnostics, then it for sure has a CRC also. Nice, very good findings, very quick findings. And here is the actual data that seems very important. We don't know what it is. So let's write unknown. This was frame byte number 5. Cool. Cool. Let's continue. One ED. One C2, one CP. Did we add? No, we did not. 4B9. That one is new. What does it contain? It seems to be just something that is counting. But we need to add it anyways. 4B9, length 1. No clue who sends. Okay, there we go. Yeah, let's continue. 3B8. We have that. $54 ABCF. 54 ABCF. Yeah, we have all those. And yeah, I realized that I could have just maybe imported this list in Sublime and deleted or done some formatting. So, you know what? Could actually add it to Excel or something, but I don't have Excel installed on this machine. That would be a good way also to filter out these messages. But I think we have added all. I can't see anything. 393, 355. Yeah, it looks good. Let's focus on this one that is from the when it's charging and see if there's something else that we missed here. 3BC. Did we have that? No. 3BC is something new. And this one is also only while charging. Let's add that. And what does it contain? It's 8 bytes long. It has something in like every byte. I will add this off camera. Or I will actually just create these really quickly. Like so. I will clean this up later on. Let's continue the search. The very interesting search. Oh, this is so much fun. Not 625. For PP we added. Okay. Maybe this video has been dragging on for quite a while already, so I guess you get the point. I will still, off camera, while I'm not recording, I will go through this and clean up these messes that I made when I didn't specify the messages. But just when closing here, some thoughts about this. So obviously, Nissan added more messages that the battery controller sends compared to the old version, and they added a lot more data onto the EV CAN bus. It seems like, or I can't tell based on the period rates here and how quickly these ones get sent, but I think the bus is more heavily loaded than before. And also a quick notice here about the EV CAN on the ZE1 model is that you can't access it via the OBD2 port. You have to splice into the wires in order to get some data out of this CAN channel. So it's quite difficult to get logs from this one. I was very fortunate to get sent these initial logs, because most people won't hack up their CAN wiring in order to take logs. But yes. Yeah, I think that's it. I will clean up this file, save it, and push it out on GitHub for everyone to look at it. And feel free to contribute to these files if you have some findings of your own that you want to share with the world. But yeah, that's it for this video. Thanks for enduring and watching. If you made it this far, yeah, congrats. Bye.